Synthetic Theory of Evolution by Juan Pablo Montoya and Michael Burnside. What is the synthetic theory?
It's the mix of classic Darwinism with modern genetics. This was formulated in the decade of 1930 and 1940. This theory states that the phenomenon of evolution is explained through mutation, accidental variation in organisms which Darwin talked about, plus the actions that are caused by the natural selection.
Daniel Frias made a revision of the synthetic theory and established that some things were missing.
The absence of a bridge between somatic and germinal cells in some phylum of invertebrates and the hereditary of somaticanal variation.
Horizontal genetic transferences and the importance of viruses in the host's adaptation and organic evolution.
The importance of heterochromatin, epigeneticists, non-coding DNA, and non-transcriptional genes. The homeotic mutation and the limitation of gradual evolution.
Excessive importance to extrinsic barriers in animal expectation.
In the first statement that Frias establishes, he means the following. Organisms have two cells, somatic, normal cells such as tissue cells, and germinal cells that are the sexual cells.
What Frias says is that the changes that happen in an organism's somatic cells can be also seen in the offsprings of that organisms.
Frias says that because synthetic theory states that changes are only reflected in offsprings when mutations happen in germinal cells, and Frias wants to show that this can also happen with somatic cells.
The second statement says that viruses and bacteria inside an organism can pass their genetic material to the host where they are through horizontal transference.
This genetic material that is transferred can help the organism by giving it genetic variability and new mechanisms that can play an important role in this organism evolution. The third statement says that heterochromatin works as a centrum for nuclear organization. Non-coding sequence works as telomeric genes. Non-coding RNA is very important for the regulation of the genetic process in an organism. The fourth statement says that there could be macroevolution that is quick and notable evolution. The fifth statement says that two species that came from one common ancestor can be in one same location because there are no enough barriers. For example, there is a new species of an orange wolf that was discovered in Antarctica. This wolf accomplishes with the statements that Frias added to synthetic theory. When somatic cells in this wolf suffer any changes, its offsprings also got these changes. This wolf had to grow more fur on his paws because the ice in Antarctica was colder and drier, so he got more fur and also did its offsprings. Because of the environment and different situations the wolf lived, he got a virus, but this virus passed him his genetic material through horizontal transference, and this helped him to get new mechanisms and genetic variability. Then, through homeosis, this wolf, after a lot of time, started to suffer a macroevolution. He started to evolve his teeth and his fur. His teeth got really big and sharp, and his fur got really long. Then, two species of wolf came from one common ancestor, speciation. One species was characterized by its sharp and big teeth, and the other by its long fur. These both species born and lived in the same area and space due to the lack of barriers in the environment they lived in. To conclude, we can say that if the things that Frias said are applied, there could be more speciation because the organisms has more possibilities to evolve and change with the change in somatic cells. The organisms can also develop new mechanisms and variation with the horizontal trespassing of genetic information. And through homeosis, the organism can enter into a process of macroevolution that is more quick and notorious in order to evolve. In this process, the organism can evolve in different ways, creating new species, as I showed on the example. And these species can live in the same area and the same space.